Namaste, myself Name-Shivi Saxena, Faculty of Physiotherapy and Diagnostics, and my discipline is Medical Laboratory Technology from Jayoti Vidyapeeth Women's University, Jaipur. So, welcome in digital version 2.0. So, my today topic is Bacteria from property. So, let's start. My topic is Bacteria from property. So, firstly, history and distribution. Filariasis has been known as antiquity. Elephantiasis had been described in India by Sushruta and in Persia by Rajas and Abyssinia. Elephantitis, so painful, disfiguring swelling of the leg and genital organ, is a classic sign of late stage disease. And the term Malabar lag was applied to the condition by Clark in 1709 in Kochi. Microfilaria was first observed by Demarque 1863 in the hydrocele fluid, a patient from Havana, Cuba. The genus is named after Boucher, a Brazilian physician who reported microfilaria exclusive urine in 1868. Microfilaria was first demonstrated in human blood in Calcutta by Lewis, 1872. In 1876, Bancroft first reported and described adult female worm, and in 1888, adult male worm was described by Warren. Manson, 1878, in China identified Incubation mosquito as an vector. This was the first discovery of insect transmission of a human disease, and Manson, 1879, also demonstrated the non-cultural periodicity of microfilaria in peripheral blood. Bacteria Bancrofti is distributed widely in the tropics and subtropics of Saharan Africa, Southeast Asia, India, and the Pacific Islands. The largest number of cases of malaria uh, occurs in India. In India, the endemic areas are mainly around the sea coast and along the banks of the large rivers. Through infection occurs virtually in all states except in the northwest. Okay, so habitat. The adult form reside in the lymphatic system of man. The microfilaria are found in blood. So morphology. Uh, so this is structure morphology of Bacteria. So adult worm. The adults are whitish, translucent, thread-like worm with smooth cuticle and tapped in end. The female is large, 70 to 100 into to 0.25 mm. Then the male, 25 to 40 into 0.1 mm. So, and the genital cell, G cells, are situated anterior to the anal. The internal, that means central body of monsoon, extending from the anterior V spot to G cell 1, representing the rudimentary alimentary system. The tail tip devoid of nuclei in Mr. Bancrofti bear two distinct nuclei in male. Microfilaria do not multiply or undergo any further development in the human body. If they are not taken up by a female vector mosquito, they die. Their lifespan is believed to be about 2 to 3 months. Okay, so it is estimated that a microfilarial density of at least 15 per drop of blood is necessary for infecting mosquitoes. So, so next is periodicity. So the microfilaria circulate in the bloodstream in India, China, and many other Asian countries. They show a natural periodicity in peripheral circulation, being seen in large number in peripheral blood only at night between 10 p.m. and 4 a.m. This correlates with the night bite habit of the vector mosquito. Periodicity may also be related to the sleeping habit of the host. It has been reported that if the sleeping habits of the host are reversed over a period, the microfilaria change their periodicity from nocturnal to diurnal. Okay, so life cycle of Bacteria bancrofti. So life cycle. Bacteria bancrofti passes its life cycle in two hosts. First, definitive host or second, intermediate host. So, definitive host, man, no animal host of reversible immune for Bacteria bancrofti. And intermediate host, female mosquito of different species act as vector in different geographic area. The measure vector in India and most other part of Asia is Culex uh, mosquito. So infective form actively motile third stage filariform larva is infected to men. Mode of transmission. So human get infection by bite of mosquito carry filariform larva. So development in mosquito. When a vector mosquito feed on a carrier, the microfilaria are taken in with the blood meal and reach the stomach of the mosquito. So within 2 to 6 hours, they cast off their sheets, uh, penetrate to the stomach wall, and within 4 to 17 hours migrate to the thoracic muscles, where they undergo further development. During the next 2 days, they metamorphose into the first stage larva, which is a sausage shape with a spiky tail measuring 125 to 200 to 15 to 10 to 15 mm. Within a week, its mold once or twice increase in size and become the second stage larva, measuring 225 to 325 into 15 to 30 mm. In another week, is developed its internal structure and become the elongated third stage filariform larva, measuring 1500 to 2000 into 15 to 25 mm. It is actively motile and is an infective form. In it enter the proboscis sheet of the mosquito, awaiting opportunity for infecting human or whom the mosquito feeds. There is no multiplication of the microfilaria in the mosquito, and one microfilaria develops into one infective larva only. The time taken from the entry of the microfilaria into the mosquito till the development of infective third stage larva located in its prophytic sheet constitute the extrinsic incubation period. So its duration varies with environmental factors such as temperature and humidity, as well as with the bacterial species under optimal condition. Its duration is 10 to 20 days. When a mosquito with infective larvae in its proboscis feeds on a person, the larvae get deposited usually in pairs on the skin near the puncture site. So, uh, development in male. The larvae enter through the puncture wound of penetrate the skin by themselves, then sleep. So the infective dose, this for man is not known, but many larvae fail to penetrate the skin by them. Sleep of many mode are destroyed in the tissue by immunological and other defense mechanisms. A very large number of infected mosquito bites are required to ensure transmission of man. So prefer as many as 1500 infective bites per person. And after penetrating the skin, the third stage larvae enter the lymphatic vessels and are carried usually to abdominal and inguinal lymph nodes, where they develop into adult form. And there is no multiplication at this stage, and only one adult develop from one larva, male or female. They become sexually mature in adult about 6 months and mate. The gravid female worm release large number of microfilaria, as many as 50,000 per day. They pass through the thoracic duct and pulmonary capillaries to enter the peripheral circulation. The microfilaria are ingested with the blood meal by mosquito, and the cycle is repeated. So, pre-patent period, the period from the entry of the infected third stage larva into the human host till the first appearance of microfilaria is circulation, is called the biological incubation period of the pre-patent period. This is usually about 8 to 12 months. Next, clinical incubation period. So, clinical incubation period from the entry of the infected larva till the development of the earliest clinical manifestation is called the clinical incubation period. This is variable, but is usually 8 to 16 months, though it may often be much longer. So, pathogenesis. So, infection caused by Bacterium crofti is a term as Vaucheriasis or Bancrofti filariasis. The disease can present as classical filariasis and occult filariasis. So, next is the laboratory diagnosis. So, the diagnosis of filariasis depend on the clinical features, history or exposure in endemic areas, and on laboratory findings. The laboratory test that can be used for diagnosis has been described. Demonstration of microfilaria. So microfilaria can be demonstrated in blood and urine and so a demonstration of microfilaria. Microfilaria can be demonstrated in blood, urine, exudate of lymph, varix, and hydrous fluid. Peripheral blood is the specimen of choice. The method has the advantage that the species of the infected filaria can be identified from the morphology or the microfilaria seen. It is also the method used for carrier survival. In India and other areas where the prevalent filaria species is periodic, It is best to collect night blood samples between 10 p.m. to 4 m. Microfilaria can be demonstrated in unstained as well as stained preparations and in thick as well as thin smear. Unstained film. So examination under the low power microscope showed the actively motile microfilaria lashing the blood cells around. The timing of blood collection is critical and should be based on the periodicity of the microfilaria. The examination may be conventional made the next morning as microfilaria retain their validities and motility for a day or 2 days to at room temperature. And steam film, a thick and thin blood smear is prepared on a clean glass slide and direct. So, flowchart laboratory diagnosis. So, direct four types of laboratory diagnosis. So, direct evidence, indirect evidence, immunodiagnosis, and molecular diagnosis. So, first, direct evidence, detection of microfilaria by examination of a thick and thin blood smear stained with zimsestin by examination of unstained amount of blood under microscope and by electrodyne orange microhermetic tube technique. And second, indirect evidence. So eosinophilia in blood and elevated serum IgE level. So next immunodiagnosis. So first antigen detection, ELISA ICT, and both tests have sensitivity of 93 to 100% and specificity of 100%, and sample can be collected during daytime. And antibody detection, so CFT, HAIFA, these tests have low sensitivity and specificity. And fourth, molecular diagnosis, so done by PCR, and the test is positive only when microfilaria are present in peripheral blood. Negative is in chronic malaria. And next statement. So diethyl carbamazine is the drug of choice. It is given orally in a dose of 6 mg per kg body weight daily for a period of 12 days, amounting to a total of 72 mg of DEC per kg of body weight. It has both macro and microbial properties. So, following treatment with DEC, several allergic reactions may occur due to death of microfilaria. It kills both microfilaria and adult worm. So, uh, and this session is completed. So, any query in mention comments box, and thank you so much. Namaste.